Okay, this video segment is we're still on the topic of vectors. And today's topic, we're going to talk about operators on vectors. Specifically, there are two types, or I categorize them as two types. They're numerical operators, or also known as arithmetic operators. So how do you do basic math with vectors? And then the other one are logical or Boolean operators. We're going to talk about logical and Boolean operators a little bit later, just because I have to build up some logic math and things like that first. So this particular video segment is going to talk more about and focus on the arithmetic operators on vectors. So let's deal with those, and let's keep our titles right here and go arithmetic. Okay, which means arithmetic. So we're going to be doing addition, subtraction, multiplication, and division of vectors, which are fairly straightforward, but there is a little caveat there. So let's talk about, before we get into addition, subtraction, multiplication, and division, so addition, subtraction, multiplication, and division, we're going to talk about one basic rule. So number one rule in this is, and we've seen this a bit before, that both vectors must be the same size. And since we're dealing with vectors, if we're dealing with arrays and matrices, size would be the word. But since we're dealing with vectors, which only have one row, we can also put same length. Most vectors must be the same length, or one can be a scalar, which we've talked about before, which means a scalar is nothing more than a vector of length 1. Okay, so primary rule in dealing with this is when you're adding, subtracting, multiplying, or dividing vectors, both vectors must be the same size or length, or one can be a scalar, which means a vector of length 1. So we'll see that come up over and over again. So that's primary rule. So let's talk about addition and subtraction with vectors. So let's go addition, subtraction. Okay, so let's say if we had two vectors. We have vector A that is 5, 6, 7, and vector B that is 4, 3, 2. Now this is really where MATLAB gets powerful. So if I do vector C equals A plus B, well, what's going to happen is we're going to add each corresponding element in vector A with vector B, which means that over here on the side, C at 0 is going to get A0, excuse me, that's wrong. C at 1 is going to get A1 plus B1. C2 is going to get A2 plus B2. C3 is going to get A3 plus B3. Okay? And once again, index is 1, 2, 3. Index 1, 2, 3. To belabor the point a bit more, if this is vector A in memory, index is 1, 2, 3, or more specifically, A sub 1, A sub 2, A sub 3, with values 5, 6, 7. And this is vector B in memory. B sub 1, B sub 2, B sub 3, with values 4, 3, and 2. Then vector C is going to be, you can almost think of it like this, it's going to be the addition of them, where C C1, C2, C3 is going to be 9, 9, and 9. Okay? Now this isn't like regular math where you would carry the values. So like if this were a 4, then this value would be 11. You wouldn't carry it over into the other side. But so this is actually a 2. So we get 9, 9, and 9. So this would result in C being the vector 9, 9, 9. Now I did that, and that was a little in depth, but I did it step by step, because if you get this concept here, then this concept holds true for addition, subtraction, multiplication, and division. So that's the basic of how you add and subtract vectors. So if I have A defined as this and B defined as this, then C equals A plus B is going to yield the vector 9, 9, 9, because you do element by element addition. Okay? Alright. Same thing with subtraction. Let's see if I can squeeze another example in here. If D equals, well, let's not go to subtraction yet. Let's go to the scalar part. So that's when both vectors are the same size. Or you can do A plus 6. It's not a B. Let's do another number. Let's say A plus 5. If you did D equals A plus 5, then this is a scalar. MATLAB is smart enough to know that since this is a scalar, it's going to add the value 5 to each element in vector A. So what's going to happen here is D is going to get D1, D2, D3. D is going to get 5 plus each element in vector A. So it will be 10, 11, and 12. Okay? So D is going to get the vector 10, 11, 12, because you add 5 to each element. This is what happens if you have a scalar plus a vector, and this is what happens when you have a same size vector plus a vector. Okay, so those core concepts hold true for addition, subtraction, multiplication, and division. So let's see it happen with subtraction. So once again, if A equals 5, 6, 7, and B equals 4, 3, 2, then if I said vector E equals A minus B, then you do an element by element subtraction. So therefore E would be 5 minus 4, which is 1, 6 minus 3, which is 3, and 7 minus 2, which is 5. So E would be the vector 1, 3, 5. And as far as the scalar one works, if I did F equals B minus 3, then you would get, the result would be, F would be 4 minus 3, which is 1, 3 minus 3, which is 0, and 2 minus 3, which is negative 1. So you wind up with this one. Once again, that's subtracting a scalar, so that 3 gets subtracted from each element, and this is subtracting a vector, so you do element by element subtraction. Okay? So that's the addition subtraction part. Now let's move over to multiplication division. Multiplication division. Okay, now there's a caveat here, and the caveat is, if you remember back in your math history, if you take a matrix or an array, depending on what you call it, and you multiply it by another matrix, that is not doing element by element multiplication. What you're doing there is you have to multiply 1 times 4 and plus 2 times 2. So you get this. So it's 1 times 4 plus 2 times 2. If you recall this from your math, and then this element is 1 times 3 plus 2 times 1, and then this element is 3 times 4 plus 4 times 2, and this one is 3 times 3 plus 4 times 1. So you get this, and then you do the multiplication and addition, and you wind up with a matrix or an array over here. So this is when you talk about multiplying and dividing vectors or matrices or arrays. You have this thing, that this is how you truly multiply them in the world of math. This is not element by element multiplication and division. This is not what we want at this particular point in time. But if we just put a multiplication sign, which is an asterisk, or a division sign, which is the slash, if we put those between two vectors, even though they're one-dimensional, MATLAB will treat them as matrices. Remember, matrix library, that's what MATLAB stands for. You're going to get, it's going to do this multiplication this way, which is not what we want. So the question is, how do we force an element by element multiplication and division, just like we had an element by element addition and subtraction? Well, the answer is, instead of using just plain old asterisk and backslash, these will do vector multiplication and division, or matrices or arrays. If we want element by element, we have to put a dot in front of it. So right now, in terms of this, in terms of what we're doing in the program, let's make sure that we use a dot in front of the multiplication and the division symbol. And if we do that, we'll get element by element multiplication and division, just like we have element by element addition and subtraction. Okay, so let's see that in action, which is really straightforward once you grasp that. Once again, if we have A equals the vector 5, 6, 7, and we have B equals the vector 4, 3, 2. Then if we did C equals A dot multiply B, then we do element by element multiplication, and so we wind up with C equals the vector 5 times 4, which is 20, 6 times 3, 18, 7 times 2 is 14. Okay? Then if we're doing, now we don't necessarily need the dot notation if we're using just a scalar. If we did A times 3, that would work. But just so that you're getting in the habit, go ahead and put that dot in there. It doesn't hurt anything, and that way you'll get in the habit of using it. So now D is going to be the vector 5 times 3, which is 15, 6 times 3, which is 18, and 7 times 3, which is 21. So you get element by element for the scalar here, and then this is element by element here. Okay, once again using the dot. So very important with multiplication division that you have this dot that you use as well. So now just to be complete, let's do division. So if I do let's see, vector E equals A dot backslash or A dot slash divided by B, then E is going to equal the values, and I have to do math on the fly real quick. 1 point, what's this, 1.2 comma 2 comma 3.5. I believe that's right. That's 1.25. Yes. So that's the division there. And then if I do F, equals A divided by 2, then F is going to be 2.5, 3, and 3.5. Yes. There we go. And so once you get the dot notation here and understand the element by element multiplication, division, addition, subtraction, and the scalar multiplication, division, addition, subtraction, heeding to this primary rule here, both vectors must be the same size or length, or one can be a scalar, then you've got it. And that's how you do arithmetic operations with vectors. It also works with the power sign. If we did exponential, that would work as well. So this works for most math operations. So this is the MATLAB reinforcement for the onboard lecture talking about operators, arithmetic operators for MATLAB. So let's jump in and create some vectors and do some arithmetic operations. Very quickly, if we have A equals 5, 6, 7, and express that, B equals 4, 3, 2, that's that. Then we do A plus C equals A plus B. We run this now. I've already saved this file, so we should see the output. If we look over here in the workspace, there's the vector A, vector B, and then the output 999, which we got on the board, and then down here in the command window, there it is, because we didn't suppress it with a semicolon. If we do D equals A plus 6, run that. We look over here, D is every element in A with 6 added to it, and the same thing down here in the command window. Same thing with subtraction. We do E equals A minus B. We wind up with 135, as we do down here. And if we did F equals A, or let's say B minus 8, and run that, we get an oops, equal sign. Okay. So equals B minus 8. Do that, and we get this vector here. Very straightforward, element by element, addition and subtraction. Let's continue. Let's do some multiplication and division. Let's see, G equals A. Remember, we have to use the dot operator or we'll get into doing matrix multiplication and division, and we don't want to do that. So A dot asterisk B is going to give us an element by element product of the vectors. And so if I do that, I get 20, 18, and 14, which is an element by element multiplication of each one. Once again, I can do scalars as well. I don't need the dot for scalars, but I can use it anyhow. Like that, each element in A has been multiplied by 6. If I do division, once again, I have to use the dot. If I do not, then it will do matrix math, and that's not what I want right now. So there's the division of every element in A divided by every element in B. And just for completeness, you can do the scalar part as well. I divide everything by 2. So J is everything divided by 2. You see that over there. So there we go. Also works with powers. So you can K equals A dot. You have to use the dot operator once again. The power symbol, or the way to raise an exponential, is the caret, which is the symbol right above the number 6 on your keyboard. So if I do this, then I'll wind up squaring everything in A. So K is every element in A squared. And then that's the scalar version. It also works in the element by element version as well. If I raise every element in A to its corresponding power of B, you get this right here. So 5 to the 4th power is 625, 6 to the 3rd power is 216, and 7 squared is 49. So those are basic arithmetic operations using vectors. Keep in mind, it all holds to the rule that the vectors must be the same size, or one must be a scale. Okay? As long as you hear that, it's fairly straightforward.